So, Devicenet day 2 is what we've got going on here. All right. So last class, we kind of went over all the stuff about Devicenet. I've got a little bit more to talk about today. We're going to watch a quick video, those types of things. But anyway, let's just start with some hardware. All right. Now, I did give each of you guys one of these, not this exact one, but something along these lines. But up here, I have this section is a Devicenet. Let's see what they're qualifying this as. A Devicenet Flex IO. I wonder if this doesn't require a scanner. But anyway, right here on the very end is a little flexible IO adapter. And that basically allows us to hook inputs and outputs up to the Devicenet network. Kind of crazy, right? Devicenet network. But yeah. Anyway, so we're able to hook the IO up with this. And that's what you've got, what you can see going on here. I have 24 volts sync inputs, and there's 16 of those. And I've got a 24 volt source output, and there's 16 of those. And the kind of crazy thing about this, to me at least, which is crazy and wonderful at the same time, is, if I could slide this, but I can't get it on there, you could add another one to this. So you can take these and just pop them together like that, and you could keep adding more and more and more things to this. All right. Now, this might be one of those reasons when you're going, now I'm understanding why that whole only 8 bytes of information is kind of limiting. Right? 8 bytes, 16 bits. That means one card, not even, because we also have to have the Devicenet IP MAC address, or the ID number, the node number, whatever you want to call it. So if I would have 4 of these cards on there, it's 1 byte, 2 byte, 3 byte, 4 bytes, probably plus a byte. Now, remember, we only get 6 bytes per when we're doing the fragmentation. So 6, 250, 128, so 64. So we have only 64 combinations. Anyway, 6 bytes. Man, I was hardly wrong. 8 wrong. 64 bits. 64 bits. So anyway, we got a lot of capability here that we can keep adding. So that's what this specific one looks like. The one that I have in the back over there, that one looks a little bit different. It's just like a dedicated I/O unit. Cam has it. It's just a little dedicated I/O unit. It has a Devicenet plug just right there on it for you, but it has all the I/O. I don't think there's any expansion on that one. So it really comes down to what do you need. You need super expandability because you're going to have a whole bunch of I/O on the Devicenet network at that location, or do you just need a few? What's the case in point for that situation? So you do need to be a little bit careful when you're dealing with this Devicenet stuff, is really what it comes down to. You also need to be careful about future-proofing, per se, because, I don't know if you can find these things anymore. And by these things, I'm not saying Devicenet devices in general. I'm saying these, this specific Devicenet device. And I know as equipment's getting older, they're like, okay, we're going to stop supporting that. Stop supporting. They're not like, oh, you can't use it anymore. No, we're not producing that hardware anymore because no one's buying new stuff. So that means the price of this stuff goes through the freaking roof. All right. It's really kind of interesting. Anytime you look at any product, there is an inverted bell curve for the price. All right. Let me quick pull up a whiteboard here, and I'll just draw what I'm talking about. Just go this way with it. So I just said there's an inverted bell curve. So if we have a little graph going on here, and at the bottom is time, and over here is money. Every item that you're buying, especially when it's related to technology. Let's just stick with technology, maybe not any item. For the most part, if you look at the price of that item, it does something like this. So I'm saying it's an inverted bell curve. So when it's brand spanking new, it's a hot commodity, right? It's like, this is the new thing. This is what you want. The price is through the freaking roof because there's not enough adoption there. There's not enough sales of the product. So to make one costs a lot more money. And there's only maybe one company making it. And then as more companies jump on the bandwagon, they start making cell phones, just call it, the price starts to plummet and it reaches its bottom point. Now that bottom point could still be $1,000, but it's not the $5,000 that it was initially. And then after it's now starting to become old and outdated and lesser people are starting to use it, the price starts to go back up again. All right? Great example of this is if, for me, Super Nintendo. On Facebook right now, someone's selling one for $150. Like, that was from when I was a kid. Like, that's such an old piece of technology. It shouldn't cost that much. But because of the not producing it anymore, and people being my age now have somewhat of disposable incomes, they're like, oh, I want to bring back my childhood. So they go buy this Nintendo, from back when they were kids. So now people are going, it's not being produced. People want it, and the price starts to go back up again. So it's this like newly introduced. It's new. Excuse my handwriting. It's mass market, and now it's like old, outdated, and maybe desirable. Put desirable in there. I can't spell. You guys can't read my handwriting anyway, but yeah. So it's desirable at that point because of the need, not because like you're like, oh yeah, I really just want, I want RAM for my computer from 10 years ago. I have a 10-year-old computer that I need a new piece of RAM for because of this whatever application needs it, and I can't stop using this computer. So I need it. That's why it's desirable. So the price, that's just kind of an interesting thing to kind of look at. So I don't know if you can get these. And the reason I just told all that story was because I had a student who was working at somewhere, I don't remember what industrial location, and they had a timer go bad on them. There was an old relay logic. Everything was hardwired. There was no PLC involved, and the timer went bad. The only place they could find a replacement timer was used on eBay. And I forget, they spent $700 or something on that timer. I'm like, you would have been better off buying a very low-level PLC, like a cheap one for like $300, putting it in there, and just saying, when this input goes high, time, and then when this happens, output. Like, very simple. They could have put a PLC in and just created one single timer on that PLC and been done with it. And it would have been cheaper for them. And then they could have added more functionality later if they wanted to from that PLC. But for their purposes, they couldn't do that, or they didn't think about doing that. They're like, we just need to replace this with a timer. We know it will work if we wire it exactly the same, yada, yada, yada. So they paid through the freaking nose for this damn timing device. So just kind of something to think about in the long run. But anyway, so this, as I said, is our little Devicenet network. We look down here, we've got everything's numbered, which is nice. We got lots of voltage, we've got lots of commons, so you can have positive and negatives going wherever it is that you need. I said these are kind of daisy chainable, which is wonderful, actually absolutely nice. And right here it does tell you this is the 1794-1816. So it does tell us our model number. I'm just going to do a quick little Google here. 94-1816. Oh, device. Let's throw that in there. So that device right now is $350 from PLC Direct. I've got no clue if that's a new or whatnot, but so not terribly expensive yet. Just this little section right here kind of is going for $140 on eBay. So not stupidly expensive, but also not stupidly cheap because it's such an old technology. Again, wonderful curve. You hit this mass market where everyone's using it. It's the cheapest it's ever going to be. You should buy a whole bunch of them at that point. But you never know how many you're going to actually need. That's the wonderful downside. So, but anyway, that is that. Now, I do want to talk to you guys, show you guys this software. I've been playing with this software. It's a little bit confusing to me. This is Rockwell Automation Integrated Architecture Builder. And I was like, oh, this is going to be some great software. And it probably is when you know how to use it properly. Not gonna lie to that there on that one. I don't know how to use it completely properly, so that's my problem. But anyway, it allowed me, there was some wizards that you could go through. And you could say, okay, I'm doing a distributed I/O one, and it allows you to say, what's going on, and all sorts of other crazy things. So it allows us to select like what type of networks we're dealing with. So let's just go ahead and say we're doing a control logic something or other, and then you could come down here and say network type is a Devicenet, and then what inputs we're using and outputs and analog and those types of things. It actually does allow you to select your type of things that you're going on, which is kind of interesting. They're kind of nice, actually. It's like, okay, yeah, you need 12 inputs. Well, you need a DC input sync card, and here's one that will work. And you can click the little drop down, and you can be like, no, give me the 32 module one instead. And personal opinion, guys, anytime you're prepping equipment, have extra I/O. All right, at least like 3 or 4 of each minimum. It will save you so much hassle in the long run because it's like, okay, yeah, we put this in. One of our outputs got burned out. Well, if you don't have any extra outputs, now you have to go source another card or replace your PLC and completely. So you have to unwire everything and put a whole new one in, or you have to add another output module to it to be able to have an output that you need. So always have extra IO available to you, whether for future proofing because you might want to add some more sensors and heaters or light bulbs or whatever, or because you're worried about equipment outputs failing. If you're going to have a failure, most likely it's going to be an output. All right, your inputs are damn near bulletproof. As long as you put the right voltage to your inputs, you'll be fine. Outputs is what you're going to break because something's going to short circuit. Your heater is going to have a short in it, so it's not going to have any resistance, and it's just going to flood current through that contact or whatever the case is. That's what you're going to blow up, most likely. So anyway, it allowed me to select everything, and then I hit finish. And I clicked on, yeah, sure, go ahead. You can regenerate things. And then once I came down here to network, I went to Devicenet. It's like, oh, there's my little network. Oh, yeah, that's the module that we just put in. Look, we can actually see everything going on with it. So it's the same one that you guys have in front of you. It's like I knew what I was doing. How crazy is that? But anyway, this was, until I just hit regenerate, allowed us to see okay, here's my power supply, and it's outputting. It's only going to use 2.85 amps, but then we could see the voltage drop. And again, when we had more devices, can I do an undo? No. It allowed me to see what the voltage drop was for each of these, at what distances, and those types of things. So it was like, hey, this is what you should be seeing in the real world, which was really quite handy. So you could try to truly estimate what everything's happening. You could say, you think and here you can see your trunk lengths. So you would think I'd be able to put this on something, just click and say, this is on this device. But again, I just think I don't know how to use it. That's what it comes down to. But so I was looking at it. It's a really neat piece of software for Devicenet for coming from the very beginning of things. All right. Afterwards, probably a little bit overkill, but I was really hoping to be able to use this and understand it well. And it's not quite living up to my standards of at least ease of use. That's the big one for me. So that one kind of let me down. Oh, it does let me just drag it, at least onto the network. You'd think I could click on these 1 meters and say this is at 10 meters, not 1 meter. But I haven't figured out how to do that yet. So, but anyway, just to me, it's a really neat piece of software, and I'm sure it's a lot better when you truly get down to the deeps of it, but not something that we're really going to be doing at this point. I did want to show you some of these connectors kind of up close and personal. So this one, that is one that you will see somewhat often. All right. In fact, there's a yellow cable there that has not this exact connector, but connectors that look just like it. There are 2 ways to retain wires. 2 normal ways of retaining wires. Either with a screw and a clamp, which is personally my preferred suggested way if you're going to have something. Option B is spring-loaded, which is what this one is. So you just shove a wire in this hole, and there's a little spring-loaded contact that when you shove the wire in, it pushes out of the way, and it kind of grabs it on real tight. And then to release it, you push these little orange tabs in. And that will then release that spring, and then you can pull the wire back out, which is convenient, I will say. All right. It definitely gets the job done. And as long as you're not pulling that wire a lot, it's fine. The problem that I've had with these types of connectors is the springs in these plastic connectors here go bad. It happened on our Fisher Technique trainers that we had for PLCs. You're pushing on them and they don't push in anymore, or they're always pushed in, and I'm like, this thing sucks. I'm screw terminals, they don't really go bad. So I really wish they would put screw terminals on there, but they put these little things. Luckily, they also have a little 24-pin connector on it, or 26, so we can just push a 24-6-pin connector in and make that work. So that's how we're using them now. But anyway, so that is one of the big ones. That's the unsealed option. Here, I wish that picture was bigger. Let's keep opening a tab and then zoom in on it. Here you can see a little, this would end up being a sealed junction box. So you can have, screw terminals here, there, and one coming up. So this would be a T-joint, and this screws back on the top and probably seals it up really nice. So you can use those little crappy screw terminals on a sealed type if you have the right junction boxes. Otherwise, you're looking at something that, maybe like that. All right. So yeah, it's all different types in the long run. It really doesn't matter. Here's a nice multi-way split, so you can have one input and 4 outputs. So you can have that, one of your not your trunk line, one of your drops come in and split the 4 different devices at that point. So, and just a reminder that you can unplug any one device and not take the network down, which is a big important deal here. Now you are seeing 5 different ports on all of these. We have a shielded cable, and then we have positive or signal, positive ground, other signal. So we do have a shielded port on there. So that's why you're seeing 5. What I find interesting is sometimes you see these colors, it's like black, blue, gray, white, and red. Sometimes I feel like you see numbers. It really kind of seems like it's a crapshoot as to what it is that you're seeing. So just something that I wanted to point out. All right, and then the other thing I want to do today with Devicenet is we're going to watch the real PARS video. It is linked on D2L, so if you want to go there and go see it, you can. It is the What is Devicenet video. But that's really all I got for Devicenet today.